physicists have created a system of two connected time crystals, which are strange quantum systems that are stuck in an endless loop to which the normal laws of thermodynamics do not apply. By connecting two time crystals together, the physicists hope to use the technology to eventually build a new kind of quantum computer. It is a rare privilege to explore a completely novel phase of matter. We encounter normal crystal all the time in everyday life, from the ice in a cocktail to the diamond in jewelry. While crystals are pretty to a physicist, the laws of physics are symmetric through space. That means that our fundamental equation of gravity or electromagnetism or quantum mechanics apply equally throughout the entirety of the volume of the universe. They also work in any direction, so a laboratory experiment that is rotated 90 degrees should produce the same result. But in a crystal, this gorgeous symmetry gets broken. The molecules of a crystal arrange themselves in a preferred direction, creating a repeating spatial structure. The fundamental laws of physics remain symmetric, but the arrangement of the molecule is not. The laws of physics also have the time symmetry. That means any experiment repeated at a later time should produce the same result. An analogy to a normal crystal, but in the direction of time, dubbing this spontaneous symmetry breaking through time a time crystal. A few years later, physicists were able to finally build one. A time crystal keeps moving and repeats itself periodically in time in the absence of external encouragement. This is possible because the time crystal in its lowest energy state. The basic rule of quantum mechanics prevents the motion from becoming completely still, so the time crystal remains stuck in its never-ending cycle. This means they are perpetual motion machine and therefore impossible remark. The laws of thermodynamics suggest that systems in equilibrium tend towards more entropy or disorder. A coffee cup sitting out will always cool. A pendulum will eventually stop swinging, and ball rolling on the ground eventually comes to rest. But a time crystal defines simply ignore it because the rules of thermodynamics don't seem to apply to it. Instead, time crystals are subject to quantum mechanics, the rules that governs the zoo of subatomic particle. In quantum physics, a perpetual motion machine is fine as long as we keep our eyes closed, and it must only start slowing down if we observe the motion, referring to the fact that exotic quantum mechanics state required for the time crystal cannot keep operating once they interact with their environment. This implies that physicists can't directly observe time crystal. The moment they try to watch one quantum rule that allow them to exit breakdown and the time crystal trying to hold, and that concept extends beyond observation. Any strong enough interaction with the external environment that breaks down the quantum state of the time crystal will make it stop being a time crystal. NASA team trying to find a way to interact with the quantum time crystal through a classical observation and black hole are better described by the deterministic role of classical mechanics. The continuum from the quantum physics to classical physics remain poorly understood. How one becomes the other is outstanding mystery of modern physics. Time crystals span a part of the interface between the two worlds. Perhaps we can't learn how to remove the interface but by studying time crystal. In the new study, magnons to build their time crystal. Magnons are quasi-particles which emerge in the collective state of a group of atoms. In this case, the team of physics took a helium atom with 2 protons but 1 neutron, and cooled it within 10,000 of a degree above absolute zero. At that temperature, the helium transforms into a condensate where all the atoms share a common quantum state and work in concert with each other. In that condensate, all the spins of the electron in the helium linked up and work together, generating a wave of magnetic energy, the magnons. This wave slows back forever, making them a time crystal, each one operating in a time crystal and brought them close enough to influence each other. Experiment can clarify the relationship between the quantum and classical physics. Their goal is to build time crystals that interact with their environment without the quantum state disintegrating, allowing the time crystal to keep running while it is used for something else. It wouldn't be mean free energy. The motion associated with time crystal doesn't have kinetic energy in the usual sense, but it could be used for quantum computing. Important because that is the basis for computation. In classical computer system, the basic unit of information is a bit, which can take either 0 or 1 state, while in quantum computing each qubit is more than one place at the same time, allowing for much more computing power. Time crystal can be used as a building block for quantum devices devices that work also outside the laboratory. In such a venture, the two-level system we have now created would be a basic building block. This work is currently very far away from a working quantum computer, but it does up interesting avenue of research. If scientists can manipulate the two-time crystal system without destroying its quantum state, they could potentially build larger system of time crystal that serve as true computational device.